want you to write this down, and then I'll give you an example, and then we'll start doing one of the homework. So yeah, a lot of writing, but that's what he discovered. Again, what is this helpful for? Because again, back in Descartes' day, he did not have a graphing calculator that could find all the zeros for him. He had to do the rational root theorem. That rational root theorem, as you could see from your question on the homework 1, 2, and 3, you could have 20 possible zeros. You were going to have to do synthetic division 20 times. Well, this actually helps determine if you do have positives or if you do have negatives. That's what this helps us for. And that's what tonight's homework, you're not going to be allowed a calculator. You actually have to do it without the calculator, without the graphing calculator. You have to do everything without. It's only 2 questions. We can do it. All right, so example of what you would have on a quiz or a test, they would say this: describe the possible real zeros of g of x equals negative 3x cubed plus 2x squared minus x minus 1. Describe them. Well, you could give it to me. You could give me all the possible real zeros. Obviously, what would be your p? What did we learn last quiz? What's our p? What's the p, y'all?
Negative 1.
So plus or minus 1. What's the q? Plus or minus 1 and plus or minus 3. Agreed? And then all the possible real zeros would be plus or minus 1 over 1, 1 over 3, and that's it, correct? So to find which ones work, you'd have to synthetically divide 4 times. But when they say this, when they say just describe those possible zeros to me, they're actually asking you about, are they positive or are they negative, and how many are there, okay? So here's what you have to do. To find how many positive real zeros are, you just count how many sign changes there are. Is this a sign change?
Yes.
How many is that?
1.
Is this a sign change?
Yes.
Is this a sign change?
No.
So how many sign changes were there? There are 2, listen to what I'm saying, possible positive real zeros, or, read the rest of this, or less than that by some even number. What would be the next even number below 2?
0.
0. Or 0. So there are 2 possible positives or 0. So either both of these are going to work, the positive 1 and the positive 1/3, or neither of them will work, the positive 1 or the positive 1/3. That's what that's saying. Okay? What about the negative? So now in order to find the negative, you have to plug in negative x. So you actually find out what g of negative x would be. So just to start us off, we'd have negative 3 times negative x to the 3rd power. What is negative x to the 3rd power? Still negative times negative 3, though, would be what? Positive 3x cubed. All right, now let's plug negative x in to this one, and we would get positive 2x squared. Plug negative x into an x, we get positive x. Have I had a sign change yet? Haven't had one sign change yet. And then minus 1. Oh, what's that?
1.
So there is 1 possible negative real zero. Or, according to this, or less than that by some even number. What's the next odd below 1?
0. Negative 1.
Well, negative 1, but you wouldn't say I have negative 1 real zero. So you would just say or 0 possible. You can't go to negative 1 real. I have negative 1 amount of real zeros. No, you just have 0. You just have 0. Okay, so again, what does that mean? Think about as if you didn't have a graphing calculator. This would be huge for you. This would be like, instead of having to do 4 synthetics, I would probably start with negative 1. And I'd synthetically divide by negative 1. Because I know once negative 1 works, I've found my 1 possible negative. Or if it didn't work, I'd probably didn't have, 1/3 probably wouldn't have worked either. So it just is very helpful if you didn't have a calculator, which we're going to have right now. So I'm going to pass out this worksheet to you. I have it here. Yep. A, list all the possible rational roots for me. That's all the P's over Q. Go ahead, do that one for me. List your P, list your Q, and then list your P's over your Q. All right, so back in my day, again, we had graphing calculators, but for whatever reason, our teacher was like, no, you cannot use them. So I would have to synthetically divide 2, 4, 6, 8 times. And that's really a pain. So if I actually use Descartes' principle, I would know if I could just divide by just the negatives or by the positives. So I'm going to use his little principle right now and see if I would just have to do the negatives or the positives. Do you all agree you should have plus or minus 1, plus or minus 2, plus or minus 4.5, right? Okay. So now let's use his rule here. So his rule again says, however many sign changes are right now is how many positive roots there are. Possible roots. How many sign changes are there? 3. Agreed? 1, 2, 3. So there are 3 possible positive or less than that by an even number. What's the next? Take away an even number from 3 is what I'm saying. 1. There's either 3 possible positives or 1 possible positive. 3 of them will work or 1 of them will work. Okay, let's try the negatives then. So now into every x, you're going to put a negative x. Negative x. Negative x. And then you're going to count the sign changes after you plug that negative in. So this would be negative 2x third minus 9 squared. Oh, there are no sign changes. That means there are no possible negatives. That's huge. That takes away me dividing by these negative right here. I would only then have to do 4 synthetic subdivisions. I would only have to then divide by 1, 2, a 4, and a 1. And actually, I would only have to really divide by 2, because if 2 of them worked, then I'd have to divide by the third. But if 1 of them worked, I wouldn't have to divide by the third. Excuse me. If you get what I'm saying. You divide by 2, and if 1 of them worked and the other one didn't, you wouldn't have to do any further. That's the beauty of this. All right, so now we got to find the roots without a calculator. Well, I know I'm not going to divide by any negatives. Not going to do that. So anybody want to take a guess what we should divide by?
Synthetic division.
By what, though?
1.
You want to start by 1?
Yeah, why not?
All right, go ahead. Do 1.
1.
Number 1.
2.
2.
If this one doesn't work,
If this one doesn't work, then what?
we still do the other two.
It's right, yeah. All right, so let's see. 2, negative 9, 12, negative 4. This one works. Good job, Gray. Okay, so I know that 2 is a root. I actually have already taken this polynomial and brought this down to a degree what now? What is this degree? 2x to the what? Squared. And you should all know how to factor right now. I mean, you could keep synthetic division if you want, but we should all be able to factor this. What 2 numbers multiply to 4 but add to a negative 5? 4 and 1, and they're both negative. And then don't forget this part. Divide by 2 and bottom up if you can. So what is this right here? What's that root? X minus 2. Bottom that up, that'd be 2x minus 1. And then don't forget about the 2 that you had already divided by here. So tell me what that tell me what that says about our graph right here.
Which was root 2.
So I have roots at 2 with a multiplicity of 2 and 1/2. That means at 2, I am going to touch. At 1/2, I'm going to cross through. Okay? So again, I'm doing this all without a calculator, as are you right now. So now I want us to graph, and I want us to graph really accurate right now. I mean, really accurate. So let me show you some things that you should know, and then you can tell me. I know for sure I do have zeros I have 2 right here, and it's going to touch, and then at 1/2, it's going to cross through. You don't have to write the T in the, I just was kind of writing that for my own benefit. Can someone tell me something else that we know and can do with this graph? It does make a little loop. We know the turning points. We do know end behavior. What's our end behavior on this one?
Down, up.
How do you know it's down, up? Very good. Cubed. Disco, it's going to start down. It's going to end up. Okay. I know that it's going to come up right here at a half, and it's going to cross through, and then it's going to come back down and touch and come back up like that. But I want this to be more accurate than that. I let you get away with that, but now we're being really accurate. So I want some other points on the graph, and I want you to get those points without the calculator. So let's see. I'll give you a point right now. Does anybody know what this -4 is on?
The y-intercept.
It is the y-intercept. Let's graph it then. Go down to -4.
Why don't we have to do the 4 and the 1/2?
Why don't we have to do the 4 and the 1/2? Because those are possible roots. Those are the ones that don't work, so. All right, so here's what I do. I know it's gonna start down. I know it's gonna end up. I want you to be more accurate though. Here's what I'm noticing. I wanna know, I know it's gonna come down, and like I said, and cross through, come back down. I wanna see how high that little loop is right here. So I have 1/2 and then I have 2. What number do you think I should plug in here? 1. And didn't I already do synthetic division for 1? What does that remainder tell you? Remember, we talked about this, the remainder theorem. What does that tell you? If I had plugged in a 1, that was my answer. So I actually already have that point. 1, 1. 1, 1. Thank you. Okay. I would say we would only need 2 more points now. Again, my picture looks like it's kind of like this big right here. It's somewhere between, I probably would find -1. I would probably want to get what that is. And then I'd probably want to go a little bit outside of this 2. So I'd go to 3. So I want some of you, you can work with each other. I want one of you to do -1, synthetically divide it or plug it in. And I want one of you to do 3, synthetically divide it or plug it in, whichever way you think is faster.
3. Wait, am I on the
So -1, -27, that's obviously off my graph, but that's down here. So that actually gives me a better idea of how like skinny this is. Comes down, comes up. But I definitely do want a 3 here. Anybody get the 3? 5. I believe that's right. And so I know it's going to come down, touch, bounce back up, and then go up there. This is how much now you know. This is how smart you are and how you can graph without a calculator. The calculator is beautiful. It helps us out. When you go to calculus, then we actually learn what's called